The James Webb Space Telescope, JWST, is recognized as the foremost international observatory for astronomical research. Its main objective is to investigate the enigmas related to our solar system, planets orbiting remote stars, and the complex formations that constitute the cosmos, including our role within it. In a revolutionary endeavor, researchers recently pointed the JWST at a star positioned 120 light-years away from our solar system. Through this action, the advanced telescope discovered persuasive signs indicating the existence of carbon-related compounds in the atmosphere of a possible ocean-covered planet located far from Earth, astonishing scientists worldwide. But how was such a remarkable finding achieved? This discovery presents a captivating view of a planet vastly unlike those in our solar system, while also prompting significant questions about the potential for life-supporting worlds across the universe. Come along as we explore this exoplanet revelation and uncover the intriguing specifics it reveals. If you're interested in staying current with the latest findings about space and beyond, be sure to subscribe to our channel, give the video a thumbs up, share it, and turn on the notification bell for updates. NASA's James Webb Space Telescope has made a pivotal breakthrough regarding the exoplanet K2-18b, a world that possesses a mass 8.6 times that of Earth. What makes this observation particularly thrilling is the identification of carbon-containing gases such as methane and carbon dioxide in its atmosphere. This finding supports previous studies implying that K2-18b might have life-supporting conditions. It seems to possess a hydrogen-rich atmosphere and a liquid ocean on its surface. The first examination of this exoplanet's atmospheric traits, within a zone where conditions could support life, was carried out using NASA's Hubble Space Telescope, significantly expanding our understanding of this system. It's important to mention that K2-18b is about 120 light-years away from Earth in the Leo constellation and revolves around a cool dwarf star named K2-18, situated within its habitable zone. Exoplanets like K2-18b, falling between Earth and Neptune in size, are uncommon in our solar system due to the absence of similarly sized planets here. The notion that K2-18b might contain substantial carbon content and a hydrogen-heavy atmosphere fascinates astronomers. Many believe such planets may provide the most promising environments for identifying potential signs of life. The discovery of methane and carbon dioxide, and the lack of ammonia, reinforces the theory that this exoplanet could feature an ocean beneath its hydrogen-rich skies. Preliminary studies have also indicated the potential detection of dimethyl sulfide, a compound on Earth associated with biological processes. On our planet, dimethyl sulfide is predominantly produced by marine plankton. However, its presence on K2-18b remains speculative and needs additional confirmation. Further observation using JWST's tools is expected to clarify whether dimethyl sulfide is present in significant levels in the planet's atmosphere. A scientist from the University of Cambridge noted that although K2-18b resides in a region where liquid water could exist and contains carbon elements, that doesn't necessarily indicate that it hosts life. Given that the planet's diameter is 2.6 times that of Earth, it is likely surrounded by a dense, high-pressure icy layer like Neptune, with a thinner hydrogen-dominated atmosphere and a surface potentially covered in oceans. Even though bodies of liquid water might exist there, these oceans could be too extreme, either too pressurized or chemically unstable, to support life as we understand it. Nevertheless, scientists have now obtained the clearest atmospheric reading of any habitable zone sub-Neptune planet so far, allowing them to detect what elements are present in its atmosphere. A team member from Cardiff University explained that they overcame observational challenges by studying how starlight filtered through the exoplanet's atmosphere. K2-18b is a transiting exoplanet, which means it dims its host star's light as it crosses in front. That's how NASA's K2 mission initially spotted the planet. During these passages, some of the star's light travels through the exoplanet's atmosphere before reaching us. Telescopes like JWST can identify the atmospheric signatures this light carries, helping scientists figure out what gases are present. The researchers plan to conduct further studies using JWST's mid-infrared tools to confirm the atmospheric components and learn more about K2-18b's weather and environmental conditions. Their long-term aim is to look for potential biological markers on life-supporting planets, a goal that could revolutionize our understanding of existence in the cosmos. Beyond this, the JWST has also made other astonishing findings. Astronomers using the telescope have spotted complex organic chemicals similar to haze or soot in a distant galaxy. This marks the earliest known presence of such molecules in space. Personally, I find this both inspiring and eerie, as these discoveries from deep space are reshaping our basic assumptions about the universe. The significance of this lies in the fact that these molecules, called aromatic hydrocarbons, were discovered in a galaxy formed when the universe was only 10% of its current age. These carbon-rich molecules, commonly found in petroleum and coal on Earth, and in air pollution like smog, are large and structurally intricate, consisting of dozens to hundreds of atoms. What makes this finding especially surprising is that such complex molecules emerged so shortly after the Big Bang, defying expectations set by traditional cosmic theories. To frame this better, the light we now detect from this ancient galaxy started traveling just 1.5 billion years after the Big Bang. Since the universe is now about 13.8 billion years old, we're observing some of its earliest stages. Even more remarkable is that the Webb telescope enabled this detection and will allow us to continue making such discoveries for nearly another billion years of cosmic history. If we could see even farther back in time, might we uncover even more of these molecules, closer to the universe's origin? This brings up deep questions about our understanding of the universe. Previously, scientists could only prove that such organic molecules existed in the early cosmos. But thanks to JWST's improved clarity, we can now identify precisely where these compounds are concentrated. Moreover, the uneven spread of these molecules in the early galaxy SP4-1847 remains puzzling. What's truly impressive is that this galaxy had already reached a mass comparable to the Milky Way and had produced similar amounts of carbon and oxygen, despite being only a tenth as old. As humanity continues venturing into the great unknown, guided by knowledge and scientific insight, we are continually awed by the vastness and complexity of the universe. Each new discovery brings us closer to solving the secrets hidden among the stars. As our global space research infrastructure progresses, it's only a matter of time before the cosmos unveils even more of its mysteries, illuminating our place within it. Share your thoughts in the comments below. If you found this video interesting, remember to subscribe and activate the notification bell. As our knowledge of the cosmos evolves, the James Webb Space Telescope keeps providing us with transformative revelations. Its observations are shifting how we think about distant planets and celestial formations, expanding the limits of our cosmic understanding. This remarkable telescope enables us to look deeper into space than ever before, unveiling questions that long eluded scientists. The detection of intricate organic compounds in ancient galaxies is only one example of how JWST is advancing our grasp of the early universe and how it has grown over time. One of the most captivating elements of these discoveries is the idea that life, or at least its essential ingredients, might exist in places once believed to be inhospitable. The detection of carbon-based substances in the skies of planets like K2-18b opens fresh paths for studying biological markers on worlds that could share traits with Earth. These compounds, including methane and carbon dioxide, are frequently linked with life processes here. Still, their presence on distant planets doesn't confirm life exists. It only invites deeper research into whether life could be sustained there. NASA's future missions will focus even more intensely on this potential. The JWST's precision in analyzing exoplanet atmospheres marks a huge leap forward. It helps scientists detect not just basic elements but also complex chemical signals that could hint at life. This detailed view is essential for evaluating whether far-off planets could truly be habitable. As our comprehension improves, so does our capacity to spot subtle signs of life, be it through atmospheric gases, organic residues, or other phenomena pointing to biology. In addition to studying exoplanets, the JWST is also offering crucial information about galaxy formation and development. By observing ancient galaxies, astronomers can map out how stars formed, how elements are distributed, and what forces shape galaxies over billions of years. This is key to understanding how our own galaxy, the Milky Way, came to be. The discovery of aromatic hydrocarbons in a galaxy that formed much earlier than ours underscores just how much we're learning about the infancy of the cosmos. As we continue exploring space, every new insight brings us closer to answering some of the most meaningful questions ever posed by humanity. Are we alone in the universe? How did life originate? What is the ultimate destiny of the cosmos? These are questions that have intrigued scientists, philosophers, and visionaries for centuries. Now, with powerful instruments like the James Webb Space Telescope, we are more equipped than ever to seek those answers. Each breakthrough broadens our perspective and takes us one step closer to uncovering the truths that lie beyond the stars.